There's a scene in Stanley Kubrick's comic masterpiece Dr. Strangelove in which Jack D. Ripper, an American general who's gone rogue and ordered a nuclear attack on the Soviet Union, unspools his paranoid worldview, and the explanation for why he drinks only distilled water or rainwater and only pure grain alcohol, to Lionel Mandrake, a dizzy with anxiety group captain in the Royal Air Force. Have you ever heard of a thing called fluoridation? Fluoridation of water? Oh yes, I've heard of that, Jack. Yes. Well, do you know what it is? No, I don't know what it is. No. Do you realize that fluoridation is the most monstrously conceived and dangerous communist plot we've ever had to face? The movie came out in 1964, by which time the health benefits of fluoridation had been thoroughly established, and anti-fluoridation conspiracy theories could be the stuff of comedy. So you might be surprised to learn that half a century later, fluoridation continues to incite fear and paranoia. In 2013, citizens in Portland, Oregon, only one of a few major American cities that don't fluoridate their water, blocked a plan by local officials to do so. Opponents didn't like the idea of the government adding chemicals to their water. They claimed that fluoride could be harmful to human health. Actually, fluoride is a natural mineral that in the weak concentrations used in public drinking water systems hardens tooth enamel and prevents tooth decay. A cheap and safe way to improve dental health for everyone, rich or poor, conscientious brusher or not. That's the scientific and medical consensus. To which some people in Portland, echoing anti-fluoridation activists around the world, reply, "We don't believe you." We live in an age when all manner of scientific knowledge, from the safety of fluoride and vaccines to the reality of climate change, faces organised and often furious opposition. Empowered by their own sources of information and their own interpretations of research, doubters have declared war on the consensus of experts. There are so many of these controversies these days, you'd think a diabolical agency had put something in the water to make people argumentative. And there's so much talk about the trend these days, in books, articles and academic conferences, that science doubt itself has become a pop culture meme. In the recent movie Interstellar, set in a futuristic, downtrodden America, where NASA has been forced into hiding, school textbooks say that the Apollo moon landings were faked. In a sense, all this is not surprising. Our lives are permeated by science and technology as never before. For many of us, this new world is wondrous, comfortable and rich in rewards, but also more complicated and sometimes unnerving. We now face risks we can't easily analyse. We're asked to accept, for example, that it's safe to eat food containing genetically modified organisms, GMOs, because, the experts point out, there's no evidence that it isn't, and no reason to believe that altering genes precisely in a lab is more dangerous than altering them wholesale through traditional breeding. But to some people, the very idea of transferring genes between species conjures up mad scientists running amok. And so, 2 centuries after Mary Shelley wrote Frankenstein, they talk about Frankenfood. The world crackles with real and imaginary hazards, and distinguishing the former from the latter isn't easy. Should we be afraid that the Ebola virus, which is spread only by direct contact with bodily fluids, will mutate into an airborne super plague? The scientific consensus says that's extremely unlikely. No virus has ever been observed to change completely its mode of transmission in humans. and there's zero evidence that the latest strain of Ebola is any different. But type airborne Ebola into an internet search engine and you'll enter a dystopia where this virus has almost supernatural powers, including the power to kill us all. In this bewildering world, we have to decide what to believe and how to act on that. In principle, that's what science is for. Science is not a body of facts, says geophysicist Marcia McNutt, who once headed the US Geological Survey and is now editor of Science, the prestigious journal. Science is a method for deciding whether what we choose to believe has a basis in the laws of nature or not. But that method doesn't come naturally to most of us, and so we run into trouble again and again. The trouble goes way back, of course. The scientific method leads us to truths that are less than self-evident, often mind-blowing and sometimes hard to swallow. In the early 17th century, when Galileo claimed that the Earth spins on its axis and orbits the Sun, he wasn't just rejecting church doctrine. He was asking people to believe something that defied common sense. Because it sure looks like the Sun's going round the Earth, and you can't feel the Earth spinning. Galileo was put on trial and forced to recant. 2 centuries later, Charles Darwin escaped that fate, but his idea that all life on Earth evolved from a primordial ancestor, and that we humans are distant cousins of apes, whales, and even deep-sea mollusks, is still a big ask for a lot of people. So is another 19th century notion, that carbon dioxide, an invisible gas that we all exhale all the time, and that makes up less than 0.1% of the atmosphere, could be affecting the Earth's climate. Even when we intellectually accept these precepts of science, we subconsciously cling to our intuitions, what researchers call our naive beliefs. A recent study by Andrew Stulman of Occidental College showed that even students with an advanced science education had a hitch in their mental gait when asked to affirm or deny that humans are descended from sea animals or that the Earth goes round the Sun. Both truths are counterintuitive. The students, even those who correctly marked true, were slower to answer those questions than questions about whether humans are descended from tree-dwelling creatures, also true but easier to grasp, or whether the moon goes round the Earth, also true but intuitive. Stulman's research indicates that as we become scientifically literate, we repress our naive beliefs, but never eliminate them entirely. They lurk in our brains, chirping at us as we try to make sense of the world. Most of us do that by relying on personal experience and anecdotes, on stories rather than statistics. We might get a prostate-specific antigen test, even though it's no longer generally recommended, because it caught a close friend's cancer. And we pay less attention to statistical evidence, painstakingly compiled through multiple studies, showing that the test rarely saves lives, but triggers many unnecessary surgeries. Or we hear about a cluster of cancer cases in a town with a hazardous waste dump, and we assume that pollution caused the cancers. Yet just because two things happen together doesn't mean one caused the other, and just because events are clustered doesn't mean that they're not still random. We have trouble digesting randomness. Our brains crave pattern and meaning. Science warns us, however, that we can deceive ourselves. To be confident that there's a causal connection between the dump and the cancers, you need statistical analysis, showing that there are many more cancers than would be expected randomly, evidence that the victims were exposed to chemicals from the dump, and evidence that the chemicals really can cause cancer. Even for scientists, the scientific method is a hard discipline. Like the rest of us, they're vulnerable to what they call confirmation bias, the tendency to look for and see only evidence that confirms what they already believe. But, unlike the rest of us, they submit their ideas to formal peer review before publishing them. Once their results are published, if they're important enough, other scientists will try to reproduce them, and, being congenitally sceptical and competitive, will be very happy to announce that they don't hold up. Scientific results are always provisional, susceptible to being overturned by some future experiment or observation. Scientists rarely proclaim an absolute truth or an absolute certainty. Uncertainty is inevitable at the frontiers of knowledge.